This is a grade 9 targeted GCSE Paper 1, and you've got an hour and a half to get 80 marks. Now, this paper was created by somebody in the community, so it's not made by an exam board. And the answers, you can get them at this link, but you have to pay for them, so I don't have anything to check my answers against. So I'm not 100% sure if all of this is right, but I'm quite confident in them. So more of a walkthrough explaining how I would do them, and it's not a definite answer, but if you look over it and see anything that I've done wrong, you can just tell me. Given that this is identical to this, find the value of b to the minus a. So, whenever you see an identity question, if you can expand something, just do it. So here you've got a squared minus bx plus bx. So the bx's cancel, and then you have minus b squared x squared, and then you want to distribute the x after. Okay, so I've got that, and then distribute the x after to get this. And now what we need to do is called equating coefficients. And what that is we have to look at each coefficient of x or x cubed or x squared or whatever. So here we'll just have a look at the x's first, so we'll just see what the coefficients are. So here on the left we have x, okay, and with that we have an a squared. So we're not looking at the x cubed, so we're just looking at the x's. So here we've got a squared, and then here we've got 25. So we can say that a squared equals 25. And now let's look at, so a equals plus or minus 5. And then looking at the x cubes now, so we've got minus b squared, and we've got minus 4. So we can say that minus b squared equals minus 4. So b squared equals 4, so b equals plus or minus 2. Now if you use this and substitute it into this form here, you'll actually get a few different answers. So you'll get these 4 answers. But the question's hinted saying it only wants one value. So this is a little bit ambiguous. But what I've done is I've just taken the principal root. So what the principal root is if you have, say, a squared equals 25 or something like that, when you square root both sides, you only take the positive solution. So say if we have b squared equals 4, instead of b equals plus or minus 2, we'll just say that b equals 2. So here I've taken the principal root, so that's assuming the principal root, and then you just want to go ahead and substitute that into this to get b to the minus a equals 2 to the minus 5, which is 1 over 32. Question 2. Freddy plays the lottery. There are 49 balls to choose from. The balls are numbered 1 to 49. Freddy chooses the 6 numbers shown below in the order in which they appear. You've got this sequence of numbers. John believes the numbers were chosen randomly. Show that John could be wrong, stating a reason for your choice. Now, the only way that John could be wrong, so the only way that the numbers were chosen systematically and not randomly, is if there's some sort of pattern to them. So this is just a sequencing question hidden in disguise. It's just a sequencing question disguised. So if we just go ahead and write out all of these numbers here, we can just find out the differences between them and see if there's an nth term to it. Because if there's an nth term, then that means there's a pattern. And if there's a pattern, then it's likely not random. So let's just find the first difference. Do that for a couple of them. So between 3 and 4 is 1, obviously, and 4 and 7 is 3. And then we'll find the second difference. Oh, I'll find that one. And then we'll find the second difference, which is 2. And then here it's also 2. And then what you can say is, because this is a quadratic sequence, and you can tell it's a quadratic sequence because the second difference is always constant. It'll always be 2 here. And so one way in which you can solve this is just by saying, oh, well, the second difference, we'll just make that equal to 2a. The first difference, so 1 here, we'll just take this side. So we'll just use this, like these 3 numbers here. Second difference, we can say that's 3a plus b equals that. So 1 here in this case. And then the first term, we can just say that's a plus b plus c. So you can just say this for every single one. So any quadratic sequence you get, you can say that the second difference is equal to 2a, the first difference is equal to 3a plus b, and the first term is equal to a plus b plus c. And then you can solve this as a system of equations now. So here we've got a equals 1, and then substitute a equals 1 into here. So you've got 3 plus b equals 1. So rearrange to get b equals minus 2. Now you've got a and b, plug that in there. So you've got 1 minus 2 plus c equals 3. So 1 minus 2 is like minus 2 plus 1. So it's minus 1. And then add 1 to both sides. So you get c equals 4. And then this will always be in the form a n squared plus b n plus c. So every single quadratic sequence will always be in this form. And then just plug in your values. So we've got, if you just plug them in, you get n squared minus 2n plus 4. Obviously the 1, you don't even need to write it in because the coefficient, if the coefficient is 1, you can just write the variable. So we've got this quadratic sequence, this quadratic nth term to represent the sequence. And that tells us that there is some sort of pattern, which means that John could be wrong. So you can say the 6 numbers chosen follow the pattern above, which shows that John could be wrong. And now he's not definitely wrong, he just could be wrong, because you could have just gotten this by chance. Triangle ABC is shown in the diagram below. AC equals x, so just label on what the question tells you, and then ACB is equal to 60 degrees. Show that the perimeter is this. So we're just, basically the question just wants you to find this side here, because you've already got these two. So if you've got the angle in between and between two lengths that you know, then it's cosine rule. So we've got x squared plus 3x squared minus 2x 3x cosine 60. So just plug that in. X squared plus 9x squared is 10x squared minus 6x squared cosine 60. And then cosine 60, you should know that as an exact value, that'll be a half. So you have 10x squared minus 3x, which is 7x squared. And then square root both sides to get just a, which is root 7x, because the x squared becomes an x and the root 7 and the 7 becomes a root 7. So that means this side is root 7x. Now if we add all these together, we'll get 4x plus root 7x, and then factor out the x like they've done here to get 4 plus root 7, all multiplied by x. Find the value of this. So if you see a question like this, just always turn every decimal you see into a fraction. So 0.16 is the same as saying 16 over 100, which is the same as saying 8 over 50, which is the same as saying 4 over 25. And then 1.5 is 3 over 2. So we have 1 over 4 over 25, all to the power of 3 over 2. Now, whenever you have a fraction like this is called a complex fraction. And what you can do with it is, if you've got a number with a fraction below it, you can just always take this number and multiply it out by here. So you can get 25 over 4. So always just take this number, multiply it by this to get 25 over 4. And then, well, this just becomes easy because you square root, because that's what you do with the denominator. So you square root first and then you cube it. So you get 5 over 2 all cubed to get 125 over 8. And then that's 15.625, yep, because it says value. I'm not 100% sure if you'd need it as a decimal, but just do a quick bus stop. It's not too much effort. Two men walk together along a road, starting at the same time. The speed time graph below shows the first 9 seconds of their walk. So we've got man 1 in this dotted line, and man 2 in this one. And so the ratio of the distance covered by man 1 to the distance covered by man 2 in the first 9 seconds, so overall, can be written in the form m to n, where m and n are double-digit integers. Find the value of m and n. So it's saying, what's the ratio of the distance covered by man 1 to the distance covered by man 2? So we'll just find out what, the distance that man 1 travels. Now, whenever you have a speed-time graph, the distance is always the area under the curve. So we'll just ignore this line here, and we'll just look at the dotted line. So we'll just look at man 1. So here we've got a triangle. So this is 2 multiplied by 4, which is 8, divided by 2, which is 6. Sorry, what? 2 multiplied by 4 is 8, divided by 2 is 4. Yes, sorry. And then we've got from 2 to 6, so that's going 4 across the bottom, multiplied by 4 across the top. So that's 16. If you're wondering how I divided by 2, it's just half base times height. And then here it's just base times by height. And then here, there's two ways you could do this. So you can say a plus b divided by 2 times by height. Or you can just split it into this rectangle and then this triangle. I just used the trapezium. So you can say 4 plus 6, which is 10, divided by 2, which is 5, times by 3, which is the height, to get 15. So add these all together to get the distance covered by man 1, which is 35. Now for man 2, let's just get rid of these. So we've got 5 multiplied by 5, which is 25, divided by 2, which is 25 over 2. And then you've got this, this across the bottom here is 4, because from 5 to 9 is 4. multiplied by 5 is 20. So it's 20 plus 25 over 2, which is 65 over 2. And now you just want this in the form m to n, so we'll just do that. It says m and n are integers, they're double digits, so just multiply out by 2 on both sides to get 70 to 65. That tells us that m is 70 and n is 65. Triangle ACD is shown in the diagram below. AED is a straight line. AB equals 3 root 5. AE equals 2BE. So AE equals 2 lots of BE. So if this is x, we can say that this is 2x. So let's just write on this information. So we'll just call this one x. So let BE equals x. That means this must be 2 lots of x. And then 3 lots of AD. So if you have 3 lots of this full line, that's equal to 5 lots of this here. Now we'll just ignore this bottom part here for now, because you might spot something, so we can actually use Pythagorean theorem here to work out what x is. Because this side squared, add this side squared, equals this side squared. And then we can just rearrange for x. So we've got 2x squared plus x squared is 3 root 5 squared. Just be careful and square it in this. So this is 9 multiplied by 5, which is 45. 2x squared is all squared is obviously 4x squared. 4x squared plus x squared is 5x squared equals 45. Divide by 5 on both sides to get x squared equals 9, so x equals 3. Just plug these values in, and I've just drawn it out again here. And then here, you can, so you can tell here that this question is actually, what it wants you to do is do this full triangle here, take away this triangle, if you notice. You can also do a plus b divided by 2 times by height, but I didn't do that. It's really not that deep. So let's use the second bit of information. So we know what AE equals now. That equals 6. So we're saying 5 lots of 6 equals 3 lots of AD. So 6 times by 5 is 30. So 3 AD equals 30. That means AD must equal 10. Okay, so this full line is 10. So let's just draw out this triangle. So we've got 10 here on the bottom. And now this is actually a similar shapes question. So from going from 6 to 10, if you ever have trouble working out what the scale factor is, just pick any number, t. So just say, let t be our scale factor. So 6 times by t equals 10. And then just rearrange for t. So that'll be 5 over 3 or 10 over 6. So the scale factor is 5 over 3. So multiply this by 5 over 3 to get this over here. To get 5. Because this cancels with this, so you just get 5. And then we'll do the area of this big triangle, which is this. Take away the area of this triangle here, which is this, to get this trapezium. So half base times by height, so you get 25. Half base times height here, you'll get 9. 25 take away 9 is 16, and then units squared, because it's area. Find the value of p. This isn't actually too difficult of a question. It just wants you to know your trig values. So cosine of 60 is a half, and then sine of 60 is root 3 over 2, I think. So yeah, just plug that in. Remember, this is a complex fraction that we saw earlier on question 2 or 3 maybe. So just take this number and multiply it out by the top. So you get 2 over 2, which is just 1. So you get 1 over root 3. And then I think I rationalized both of them. Yep. So the way you rationalize is multiply by root 3 on both sides. So you have root 3 over 3. Then root 12 over root 12 is 10 root 12 over 12, which simplifies to 5 over 6 root 12. I don't think I did that though. I think what I did was I simplified this root 12 into a 2 root 3 and then multiplied that 2 by the 10. So you have 20 root 3 over 12. 20 root 3 over 12. And then what I did was I divided by 4 on both sides to get 5 over 3 and root 3 plus root 3 over 3. And then that gives you 6 root 3 over 3 all squared. Oh yeah, so 6 root 3 over 3, and then 6 divided by 3 is 2 root 3. So you have 2 root 3 all squared. 2 squared is 4, root 3 squared is 3. So it's 3 times by 4, which is 12. A, B, C, and D are all points in the circumference of a circle as shown in the diagram below. Angle DAB, so DAB, is this, BCD is that, and CDA, where's CD, this is that, and ABC is this. The line is drawn from D to X, okay? And CDX, so this, is x squared minus 70. Prove that ADX is a straight line. Okay, so one thing to keep in mind here is that angles on a straight line sum to 180 degrees. So that's probably what we're going to be using. Well, it definitely is what we're going to be using. So there is actually, I think, another way to do it using point area or what was it? So current area and corresponding angles, I think. Yeah. But you can't use that. You can't just use that to get your answer, because that means you've made the assumption that ADX is already a straight line. I'll get to it in the end anyways. So we've got DAB is this and BCD is that. So this is a cyclic quadrilateral, meaning opposite angles sum to 180. So if we do this, add this, that must equal 180 degrees. Because opposite angles in a cyclic quadrilateral sum to 180 degrees. So just do this carefully. So you've got 2x squared minus 5x plus 4x. So you've got 2x squared minus x, and then that's minus 96, I think. Yeah, so minus 96. And then I took 180 away from this side to get 2x squared minus x minus 276. I use the AC method to factorize. If you don't know what it is, all you do is multiply this, the coefficient of x squared, by this, and then you just factorize that to get this, and then you divide by the coefficient of x squared that you originally got rid of. And if it's divisible by it, then you just simplify it. But if it's not, then you bring the two forward, like that. I'm not really going to go into too much detail. You just use whatever way you like to factorize. But anyways, you'll get this. So just solve for that. So x equals 12 or x equals minus 23 over 2. Now, you have to discard one of your solutions. Just by looking at this, the answer for x is likely going to be 12. But we'll just check both of them just in case. So, I think I picked angle DAB. So just substitute into anyone. So, I got this, and then I just did a quick plus stop to get 66.75 for angle DAB. Now, if angle DAB is 66.75, this angle BCD must equal 113.25, I think. So it must equal 180, take away this, basically. So we'll just substitute in x equals minus 23 over 2 into this one here, so this one. Now, I'm not going to bother solving this, but I know for a fact that this is just going to be negative, and obviously you can't have a negative angle, so the answer definitely can't be x equals minus 23 over 2, so x must equal 12. Okay, so we'll just put that there, x equals 12. And then we'll do the exact same thing, but with the y ones now, so we'll do this one, add this one, equal 180. Same thing. So minus 15y plus 5y is minus 10y. Then 90 minus 6 is 84. And then take away 180 to get that. Then just factorize normally. So you'll have y equals 16, y equals minus 6. You need to discard one of your solutions again. So obviously, here it's a bit more easy, because you can just say, well, if we plug minus 6 for y, for here, well, you'll definitely get a negative answer. So y has to be 16. So yeah, you can use that. We've got angle C dx, so we can just use that. What am I looking at here? So CDA. Oh, okay, so I've just plugged in the values for CDA to get what this angle is. So I got this as 106 degrees. CDA. So I'm just plugging y equals 16 into here, and then now I can get this angle, because I've got what 12 is. I got what x is, I mean, and it tells me that it's in this form. So I'll just plug in x equals 12 into this to get 74 degrees. So this is 74 degrees. Now, if you notice, if you add these together, you'll get 180 degrees. Therefore, because it's 180 degrees, ADX is a straight line. Now, what I meant last time was, I think I've written it here, yeah. So you cannot use complementary angles or corresponding angles because you would assume that ADX is a straight line to do so. So what I mean here is, because obviously very early on we figured out that x equals 12, so that gives us this angle here. Now you can't use this angle here to work out what this one is and this one, because you'd have to assume that this is already a straight line to do so. But you can't make that assumption yet because you want to prove that ADX is a straight line. First 5 terms of an arithmetic sequence are this. Show that 4x squared minus 3 is not in the sequence. So in an arithmetic sequence, you're going to be adding by the same amount each time. So we can just say, oh, well, 2x minus brackets x plus 1 close brackets is x minus 1. So we're saying that the common difference is x minus 1. So to get from here to here is x minus 1. Now, because in an arithmetic sequence it's equal everywhere, that means the common difference between these two must also be x minus 1. I could also have picked these two or these two, but this is a weird fraction and I don't want to have to deal with it, so I'll just ignore it. So I'll just pick these two instead. So I'll do 5x minus 3 minus bracket x squared minus 2 close bracket. So that's the common difference there. Just do that normally to get this. Now this is also the common difference. So we've got two common differences and they must be the same because it's an arithmetic sequence. So you can just set them equal to each other. Then rearrange to get x squared minus 4x equals 0. And then factor out the x to get x equals 0 or x equals 4. Okay, now we have to discard one of our solutions, obviously, so we'll just plug in both of them. So if x equals 0, then you'll get this. Now, if you just have a look at this, there is no pattern to this, so x definitely cannot equal 0. If you plug in 4, you'll get this. And you notice here that it increases by 3 each time, which means x definitely equals 4. So I think I went ahead and found the nth term. Oh no, I've just plugged in x into this. So I have x squared, so 4 squared is 16, times by 4 is 64, take away 3 is 61. So we want to show that 61 is not in the sequence. So whatever the nth term of this is, because this is the same as this, we need to set that equal to 61 to find out if 61 is a term. So this is 3n plus 2, so it's just the difference between these two, which will give you 3, and then it's how do you get from 3 to 5 to the first term? Well, you add 2, so it's 3n plus 2. And then we're saying that equals 61. And then, so take away 2 from either side to get 3n equals 59. And 59 divided by 3 is a decimal, but you can't have a decimal position, because what n represents is the position, or the term, is the position inside of the sequence. And you obviously can't be 4.3 into a sequence. You have to be an integer into the sequence. So it's not in the sequence. I actually forgot to get rid of that. Anyways, so a solid hemispherical piece of gold with diameter 1.2 times 10 squared centimeters is to be melted into identical solid cuboids. The dimensions of the cuboids are 30 centimeters, 12 centimeters, and 10 pi centimeters. Find the number of cuboids that can be made from the hemisphere. You may assume there is no wastage in the production process. So here we've got 1.2 times by 10 squared. So 10 squared is 100. 1.2 times by 100 is 120. So that tells us the diameter is 120. So the radius is 60. Now, you do get given this formula here for the volume of a sphere and then the surface area of a sphere. And we'll be using this. So you don't have to remember this. But you might also notice that to get from this to this, you actually integrate, which is pretty interesting. Anyways, so solid hemispherical. So it's hemispherical. That means it's half the volume of a sphere. So we'll just do a half of this, which gives us 4 over 6, which is 2 over 3 pi r cubed. So we're using 2 over 3 pi r cubed, and we've got the radius of 60. So just plug that in. Now, the question here is, can you do this without a calculator? Because remember, this is paper 1, so it's non-calculator. Well, what you can do is, well, 60 is the same as saying 6 times by 10. Okay? And see, this becomes much easier because I know that 6 cubed is 216 and 10 cubed is 1000, obviously. So it's like saying 216 times by 1000 because we've just cubed both numbers here. So 216 times by 1000 is much easier to do. It's just 216,000. then times that by 2, or you can just divide by 3 straight away if you wanted, actually. But anyway, so you'll get 216. If you wanted to times by 2 first, so you'll get 432,000 over 3. But I think what I did was I did 216,000 divided by 3 to get 72,000, I think. So 72,000, yep, times by 2 to get 144,000 pi. And that's the volume of gold. So we'll just plug that there. So we have the volume of gold. So the total gold we have is this. And we want to melt them into cuboids now. So a cuboid, obviously the volume is this times this times this. So length times width times depth or height or whatever you call it. So yeah, just multiply all these together. 30 times by 12 times by 10. Now, you can do this as 10 times by 30, which is 300. And then 12 times by 3 is 36. Times by 100, which is 3,600. And then the pi, obviously, don't forget that. So that's the volume of cuboids. Now, you want to know how many of these cuboids you can fit into that. So what you're saying is this divided by that. So we'll do that. Cancel the pi's, cancel a few zeros to get that. And then if it helps you, you can just reduce it. So yeah, so do 720 over 18. So I've divided by 2 on both sides. And then you can divide by 2 again to get 360 over 9. Now here you might just notice that, well, 9 times by 40 is 360. Or you can just go again to get 120 over 3. Which, I mean, you should tell now that it's 40. Or you can just do a quick plus up if you prefer. So 40 cuboids. 2 functions are given below. Here are them. State which of the following graphs could be used to solve the equation f of x equals g of x. You must give a reason for your choice. Now, here, let's just have a look at this. So, we've got a quadratic. And then, what we've got is r over x. Now, if we have r over x, then that means that there's going to be some sort of asymptote. So, x can never be 0. So, if you imagine x equals 0 here, x will never touch this y-axis. Okay, and that's just for this graph alone, not for f of x equals g of x. So here we can just straight away get rid of one of the graphs, and that's c, because, well, c is linear, it's a straight line, but here we know that we have x squared, because x times x is x squared. So you don't even need to fully expand this. You can just see, well, that's x squared, and we know that that's curved, so it can't be c. Okay, and now, well, you can also say here, well, we know that it's going to be positive, because every x here is positive. I've just set these equal to each other, by the way, because the question told me to. So it definitely can't be this upside down graph, because this upside down graph is minus x squared. And then here, you do not have to fully expand. I've just fully expanded to make it clearer for you guys, but you don't have to do that. It's unnecessary. So just expand and then multiply by x on both sides, and you notice you'll get a cubic. Now, if you've ever seen what a cubic looks like, and you should have, it looks something like this. So this is just a random cubic. So you can see that it intersects the x-axis 3 times, because of, the 3 here. So there must be 3 solutions, unless it's repeated roots. Okay, so it intersects the x-axis 3 times. Now, it doesn't always have to, obviously, because of this case here. It could just do it once or twice or whatever. So here, well, which of these 2 graphs looks similar to this? Well, I mean, if you use common sense, you can find out that it's A. And B is a quadratic. Well, this is a quadratic, but this isn't. So it definitely can't be B. So it's not B, it has to be A. A is inversely proportional to B cubed, to the cube of B, cube root of B, or B to the 3rd, and C is directly proportional to the square of B. When this is this, just read that. So A is inversely proportional to B to the power of 1/3. So just write that. Yeah, you should know that something's inversely proportional. It's 1 over whatever that thing is, and that must equal A equals K over B to the 1/3. Now, this K comes from, it's just a constant, which tells you kind of like the factor or the difference in between each point. It's hard to explain right now, but I could maybe do something on it in a different video. Anyways, so just plug in the value. So it says when A equals a half, b equals 64. So just plug that in. Now the cube root of 64, because this is just the cube root, is 4. And then just multiply out. So you get 4 over 2, so 2 equals k. So k equals 2. Okay. And then I've just plugged that back into this. So a equals 2 over, and then the cube root of b. Same thing here, so c is directly proportional to the square root of b. So c equals kb squared. Now, do not plug in your k value for this, because this could be a different k value, because these are two different proportions, okay? So here, I should have actually used a different variable, but I don't care. It's not really important, because, I mean, I know what I've done. So when c equals 15, b equals 5. So just plug that in. So 5 squared is 25, 15 is 15. And then divide by 25 on both sides to get 3 over 5 equals k. So just plug that into this to get c equals 3/5 b squared. Now, we want to express c in terms of a. What that means is saying c equals something, 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 and then in that something is an a. So let's just rearrange this. So we'll multiply by b to the third on both sides. And then we'll divide by a. And then, so this is the cube root of b, because b to the third is the same as the cube root of b. So we'll just cube both sides to get b equals 2 over a all cubed. And then, so we can just plug this into here to get 3/5, and then I've just plugged this b into that b there to get this. Now you've got a power to a power, so they just multiply out. So it's 2 over a to the power of 6. 3/5 stays the same. And then I think I actually evaluated this. So 2 to the 6, well, 2 to the 5 is 32, so 2 to the 6 is 64. And then 64 times by 3 is 192, I think. Yep. And then a to the 6 is just a to the 6, multiplied by 5, so it's 5a to the 6. Mr. Lucky plays 2 games. The 2 games are game A and B. Playing game A and playing game B are independent events. The probability that Mr. Lucky wins both games is 9 over 25. The probability that Mr. Lucky wins game B is 4 times greater than the probability of him losing game A. Find the probability that Mr. Lucky wins only one of the 2 games he plays. You must show full workings. Okay, so let's just draw a tree diagram. You don't have to. You could just do this just by writing P equals P and then brackets, whatever the probability is. So let's just label it game A and game B. So if he wins both games, okay, yeah, I'm jumping ahead. So we don't know what the probability of him winning one game is. We just know if he won 2 games. So let's just say the probability that he wins 1 game is x. So that means the probability that he loses is 1 minus x. Okay? Because probabilities add up to 1. So 1 minus x is the probability of him not winning, basically, which is losing. So we'll just say, okay, we'll just draw this tree. So if he wins here, we'll call that x. If he loses, we'll call it 1 minus x. Wins again. Well, the probability of him winning the second game, so game B, is 4 times greater than the probability of him losing game A. So him losing game A is 1 minus x. So winning game B is 4 times by this. So it's 4 minus 4x. And then that means the probability of him losing this game. Oh no, sorry, I've just filled in this next one. Okay, so it's the same thing. Now, that means the probability of him losing game B is 1 minus 4 minus 4x. Because probabilities still add up to 1. So just do 1 minus that. But just be careful here. So the minus distributes. So this minus minus will become a positive 4x. So you have 4x minus 3 of him losing the second game. Okay, now this is helpful. So we can do, because we know that the probability that he wins both games is 9 over 25. So win-win. So this times by this is 9 over 25. So we'll just do that. X multiplied by 4 minus 4x is 9 over 25. Distribute the x to get that. Multiply by 25 on both sides to get that. Now, this is quite a hard quadratic to solve at first. I just used the AC method, I think. Oh no, I didn't. I just did it normally. Okay, so yeah, it just factorizes to that. It doesn't take you too long to do it. It's not as hard as it looks. Anyways, well, let me just check that. So, yep, okay, that's fine. Yeah. Okay, so that means 10x equals 9 or 10x equals 1. That means x equals 9 over 10 or x equals 1 over 10. Now, the problem with this is that they're both positive, and it's a bit harder to check which of the answers it's actually going to be. But it's not too hard, so we can just substitute values in and see which ones work. So let's say if x equals 1 over 10. So the probability of him winning 2 games will be 1 over 10 multiplied by 4 minus 4 multiplied by 1 over 10. So this, so probability of win-win is, if you just expand this out and simplify, you get 9 over 25. And we want 9 over 25, so it could be 1 over 10 for x. But we'll just check 9 over 10 just in case. So we'll substitute 9 over 10 in. So we get 9 over 10 multiplied by 4 minus 4 times by 9 over 10. So we have 36 over 10. 4 minus 36 over 10, which is 40, minus 36 over 10, so it's 4 over 10. And then 4 times by 9 is 36 over 100. 36 over 100 is the same as 18 over 50, which is the same as 9 over 25, like we want as well. So far this hasn't helped us, because it could still be either one. Okay, so both of these give us the answer we want for a win-win. So let's try win-lose maybe. We'll try x equals 1 over 10. So we'll just plug in 1 over 10 for win-lose. And we'll see what we get. Well, if you put it in, you'll find out that we get a minus probability, but you can't have a negative probability. So that means x cannot be 1 over 10. So it has to equal 9 over 10. Okay, so whenever you have two values, and they both seem right, but you're not 100% sure, just substitute values in, and then eventually you'll find out that you need to discard one of them. So that means x equals 9 over 10. Now, what do we want? So we want the probability that he wins only one of the two games. So winning one of the two games is like winning and losing, or losing and winning. So probability of winning and losing, just substitute 9 over 10 into x multiplied by 4x minus 3. And then simplify to get 54 over 100. So there's a 54% chance that he wins the first game, and then he loses the second game. Now, the probability of him now losing or winning, because he's still winning at least one game, is, we'll just solve for it. So just same thing, so 1 minus 9 over 10 multiplied by 4 minus 4 times 9 over 10. Simplify to get 4 over 100. Okay, and it's this or this. And whenever you hear an or in maths, it just means add. Okay, so it's this or this, which is the same as saying 54 over 100, add 4 over 100, which is 58 over 100, which is 58%. It doesn't matter whatever you put it as. But yeah, so the answer is 58% or 58 over 100. So the diagram below shows a triangle ABC with a shaded square drawn inside. Triangle ABC is half of an equilateral triangle, and triangle BAC, an angle BAC is 90 degrees, so this is 90. The shaded square touches the lines AB and AC and has a side length of a quarter, AB. So that's a quarter AB and that's a quarter AB because it's a square. And we'll just use this information. So I'll just explain what it's actually saying here. So ABC is half of an equilateral triangle. So the full triangle actually extends past this, and it'll meet up with the point B here. So we'll go up like this and then like that. Okay. And we want to show that the ratio of the area of the triangle, and it's this triangle here, not the equilateral triangle, to the area of the square is 8 to root 3. So what you can do here is, because you've not actually been given any values, you can just pick your own. If it's a ratio, then you can just say whatever it is, because eventually it'll simplify and reduce down to this ratio here. Now, you could say the value is x or y or a million or 12 or 15. I picked 12, so I've just pick a blank. If you wanted to pick AB, if you wanted to pick BC or AC, I don't think AB, BC would actually work, but yeah, so just pick AC or AB, whatever you want it to be. I've just said, let AC equal 12. So this length here is 12, okay? And that helps me because, well, if this is half of an equilateral triangle, that means the full equilateral triangle must have a base of 12 here and then 12 there, so 24. Okay, and in an equilateral triangle, all sides are the same. So if this full bottom base is 24, that means this must be 24 as well. This isn't 24 because that's the line going from the middle of the base up. So that's not actually lines on the perimeter. So we don't know what this one is yet. So using this, AC equals 12, we can set that BC that equals 24. And here we can use Pythagoras to work out what AB is. So 12 squared plus whatever this squared equals 24 squared, or 24 squared minus 12 squared equals AB squared. Now, 24 squared is, so it's 28 times by 2, which is 56, 560, and then add 16 from 4 squared. So it's 576 minus 144 equals AB squared. And then that gives you 432, and then square root both sides to get AB equals root 432. Now, you can just simplify this. So 144 times by 3 is apparently 432. So that's 12 root 3 for AB. And then a quarter of it is the length of this triangle here. So we'll do a quarter of that to get 3 root 3. So this one side here is 3 root 3. And now we want the area of the square. Well, all the sides in the square are the same. So I'm like, so this is 3 root 3 multiplied by 3 root 3. So it's 3 root 3 all squared, which is 27 units squared, which is the area of the square. Now we can work out the area of the triangle. So we know that AB is equal to 12 root 3, and we know the base. So it's half base 12 times by height 12 root 3. So just do that over here. You'll get 72 root 3, and then just put it in the ratio that they want. So we've got area of the triangle to the area of the square. So it's 72 root 3 to 27. So you get that. And then here you can divide by 3 on both sides. Is that what I've done? Now I've divided by 9 to get 9 times by 8 is 72, and then 9 times by 3 is 27. And then we want this in the form 8 to root 3. So I've divided by root 3 on both sides. Have I done that? Well, what I've done is I've divided by root 3 on both sides, and then I've rationalized this. So I've done root 3 over root 3. So it's 3 root 3 over 3. So it's 8 to 3 root 3. And then I've divided by 3 on both sides to get 8 to root 3, as they want. The region R, shown in the diagram below, is defined by 3 inequalities. Find the 3 inequalities in this form, where A, B, and C are integers. Okay, so just remember, gradient is change in y over change in x. If you've not seen this symbol before, it's delta, and delta just means the change in something. So the change in x, change in y. So just that. I think I started with this line first. So the change in x here is 0.4. The change in y is between 4 and 12 is 8. So it's 8 over 0.4. I've just done it like this. So it's basically just how I've described it to you guys, but I've shown it in more steps here if you want to stop and look at that. But you'll get the gradient here is 20. But because this is going in this direction, so not that one, it's actually minus 20. Is that what I've said? Is that even what I've checked? Oh no, so I've done this one here. So I've actually done this line here. So I've said 8 take away 4, which is 4. So that's to change in y, and then over the change in x, so it's 0.2 from 0.5 to 0.6. So I get that gradient is 20x. So y equals 20x plus c for this. And then we can find the y-intercept. What we can do is we can just pick a point that we know is on that line. So this point is definitely on that line. This point is definitely on the line. We'll just pick this one because it's a smaller one. And then just plug in. So x equals 0.4, which is the same as 2 over 5. And then y equals 4. So just plug that in. To get this, 20 times by 2 is 40. 40 over 5 is 8. And then 4 take away 8 is minus 4. So c equals minus 4. Plug that back into there. So y equals 20x minus 4. Now, whenever you want an inequality, to get an inequality from this, for the record, this is going to be a greater or less than or equal to sign because the lines are not dashed. They're actually straight lines that are not dashed. So if you ever want to find out if this is greater than or less than, what you do is just pick a point that you know is definitely in the region R. Okay, I'll just pick this one. So we'll say the test point is 0.46. Okay, so we'll just pick this point and we'll check to see if y is greater there or x. We'll just see, which side is heavier in terms of value. So we'll just plug in the values for x there and y. So what I've done is I've just picked a point in the region that we want. Okay, it can be any point. So I could have picked this one, maybe that one. I could have picked that one or that one. And I've just picked this one because it's just an easy one. And then I'll plug in the coordinates of this point into this. Okay, so I'll just plug it in to get this. So I have 6 equals minus 8 minus 4. So we're saying that 6 equals 4. Well, 6 definitely isn't equal to 4. But what we can say is that 6 is greater or equal to 4. The reason why it's equal to as well is because, like I said, it's not a dashed line. So if it's ever not a dashed line, it means there'll always be an equal to sign there. Okay, so we'll just put that equals that symbol into there. So y is greater or equal to 20x minus 4, and then just put it in this form. So minus 20x and then add 4. So do we want no? So we want this. We want the 4 minus 4 on that side. So the c on that side. So we'll just leave that there. We'll use the same test point for every single one. I think I went with this one next, maybe. So this would be a difference in y of 8, and then a difference of x in 0.4. Did I pick that one? Yes, I did. So complex fraction again. So 8 over 2/5. So 5 times by 8, which is 40 over 2, which is 20. But because it's going in that direction, it's minus 20. Okay. You could have also just done it as 4 minus 12. And then you'll just get a minus 20 from that calculation. It doesn't make a difference, as long as you know that this should be minus. So y equals minus 20x. And now you can say that the y-intercept is 12 just by looking at this graph, because you can see that, well, it definitely touches, this line definitely touches the y-axis at 12. So you can just plug that in straight away. You don't need to put in any points. We'll use the same test point again. We'll use this one. So a region that's a point that's definitely in the region. Just plug these value for x and y in. Simplify to get that. So we're saying that 6 equals minus 8 plus 12, which is 4. So 6 equals 4. It's not the case. So 6 is larger or equal to 4. Remember, because it's not a dashed line. And then just plug that symbol back into there to get that. And then just put it in the form. So add 20x. So y plus 20x is greater or equal to 12. Last one here. So this one. So we've got a difference in y of 4. And then a difference in x of 0.6. So we'll get that one as minus 20 over 3. Remember, I got it as 20 over 3 in my calculations, but I know that it's going in that direction, so it's a minus 20 over 3. So y equals minus 20 over 3x plus 12 again, because remember, same y-intercept. Plug in the test point. Well, you get this. Now, I haven't bothered finding out what the value of this is, but I know for a fact that any decimal, add 12, will always be bigger than 6, if that decimal is, if that number is positive. So we know that it's definitely going to be facing in this direction. Okay, so 6 will always be less than or equal to 8 over 3 plus 12. Okay, so just plug this symbol into there. And then add minus 20 over 3x. But I think what I've done first is I've actually times by minus 1 on both sides. Have I done that? Yeah, so when you multiply or divide by minus 1, the inequality reverses directions. And the reason why we wanted to reverse direction is because, well, if you look at this, it's facing in this direction in the question. So they've tried to be a bit sneaky here, and you might drop a mark if you don't notice that. So you want it to be facing in that direction. Okay? And yeah, so you could just do it. No, so yeah, just do it this way, yeah. So if you multiply or divide by minus 1, an inequality always changes the direction it's facing. So if it was facing right, it'll go to left. If it was facing left, it'll go to right. So just multiply by minus 1 on both sides to get that. So minus y is greater or equal to 20 over 3x minus 12. Okay, so it changes direction. So whenever you multiply or divide by minus 1, the inequality reverses direction. And now we can get that in the form we want. So minus y minus 20 over 3x is greater or equal to minus 12. So that's the last inequality. Two vectors are defined as follows. A to C is this, A to B is that. Find the value of cosine ACB in its simplest form. Now there's actually a couple of ways to do this question. I'll show you the GCSE way, and then I'll show you a more A-level further maths way to do it, using a nice formula. It's the dot products, if you've ever heard of that. But anyways, I'll just show you this normal way. So let's just pick a point for A or for C. It doesn't matter. So just pick a random point. We'll call it 0, 0. Okay, and we know that from A to C, let's just call this point A. From A to C, we're going 2 to the left, because it's minus 2, and then 1 down. So we've got minus 2 and 1. So if we call this A and this C, from A to C, we've got 2 left and then 1 down. And then we'll just join that up. So we've got B here. And now from A to B, well, we've got 1 left and then 4 down to get us here. Okay, so this is a rough sketch of what it should look like, right? And then, yeah, so 1 left, 4 down. And then that tells us that this length AB is the square root of 4 squared plus 1 squared. So it's just Pythagoras theorem. So it's 4 squared plus 1 squared, which is 16 plus 1, which is 17, and then square root 17, which is root 17. So AB equals root 17. Now we can find out the next one, so from A to C. Well, if it goes 2 across the top and 1 down, then that means it's 2 squared plus 1 squared, and then the square root of that. So 2 squared is 4, 1 squared is 1, 4 plus 1 is 5, square root of 5 is just square root of 5. Okay, and now we want to go from C to B. Now, be careful here, because this is the trickier one of the two. But what we can do is, we'll just say that A is the point 0, 0, because that's what we've assumed this entire time, basically. So if A is the point 0, 0, that means C is the point minus 2, minus 1, because we've gone 2 left and then 1 down. Okay, and now from A to B, well, we're going to the left by, from A to B, so from here, we're going to the left by 1, and then we're going 4 down, so it'll be minus 1, minus 4 for that coordinate. Now from C to B, well, to get from minus 2 to minus 1, we add 1, so we're going 1 right, and then from minus 1 to minus 4, we want to take away 3. So we'll go 3 down, okay? Yeah, I've just done it that way, it makes no difference. So 3 down, 1 across, 3 squared is 9, 1 squared is 1, 9 plus 1 is 10, square root of 10 is just square root of 10. Now this is helpful because we can actually use cosine rule, because remember, so if we have an angle with the both lengths in between, on either side, I mean, we can find out what this length is. But it also works the other way, so if we know what these lengths are in this one, we can find out the angle in between, because we can just call that cosine or whatever. So this is the formula, you should know it. I think you actually get given it now, but anyway, so square root of 17, the square of root 17 is 17. B squared is, we'll just call that B, and that's C. Just plug in the values. So this will be 5, this will be 10, this will be minus 2 root 50 cosine A. So 17 equals 15 minus 2 root 50. What have I done here? So then I've taken away 15, I think, have I? Yep. And then I've divided by minus 2 root 50 on either side. And then I've done inverse cosine of either side. Oh no, I've not done that. You don't need to find the angle, actually. You just want to find out what cosine ACB is. So here I've just rationalized. You can divide by 2 on both sides, actually, now that I'm looking at it. Oh yeah, I did do that, actually. And then so root 50 times by root 50 over root 50. Yeah, I've just brought this minus here. It makes no difference. It doesn't matter if it's here or here or here. It's the same. So root 50, rationalize that, to get root 2 over 10. So this is the level further maths ways to do the question. And to do it this way, you need to know a formula called the dot product. Now, the dot product is this. So it's A dot B equals, now this sign here, these two signs here, the side of the A, just mean the magnitude of A and then the magnitude of B. So what the magnitude is just the length of that line. So we'll A and B are the vectors that we're going to apply this multiplication to. Okay, and we'll find out what they are later. So here we want cosine theta, and so theta here is the angle in between A and B. Okay, so we'll rearrange for it. So we have A dot B over the magnitude of A multiplied by the magnitude of B. Okay, so I've just drawn out a simple diagram here. Now, so the way that this formula works is your theta, in this case it's here, whatever the angle is, you want the vectors that are coming out of it. So if you want this angle here, you want the vector c to a and then the vector c to b. Okay, so you want to go from c to a and then c to b. You do not want to go a to c like we have, or a to b, because that a to b just doesn't help us in this scenario. So we need to somehow go, instead of going from a to c, we need to go to c to a. Now, if you remember in vectors, whenever you're going backwards, you just multiply by -1. So this a to c, if you want to go from c to a, it'd be 2 and then 1. And a different way to think about that is, well, if we're going from a to c, we're going 2 left and then 1 down, because that's 2 left, 1 down. And if we want to go from c to a, well, we'll go 2 right and 1 up. Okay, so it's opposite. So 2 right and 1 up. Now, from C to B, well, I mean, we worked out coordinates for this. So this was -1, 4, and this was -2, 1. -2, -1, and then A was 0, 0. So from -2 to -1, well, we'll go 1 right. So we add 1. So we go 1 right. Then from -1 to -4, well, we'll go 3 down. Okay, you can just remember that from the other slide where we had a look at the coordinates. So from C to B, well, we'll go 1 right, 3 down. So that's 1 on the top and -3 on the bottom, like that. Okay. Now, what A dot B is, we'll just focus on this top part here. It's this multiplied by this, add this multiplied by that. Okay. So that's where that comes from. So this here multiplied by that, and this multiplied by that. So just do that there. So it's 2 plus -3, so it's -1 over this equals cosine theta, or cosine ACB. Now, the magnitude of A, well, to calculate that, you can just use Pythagorean theorem, normally. Now, that is basically what we're going to be doing right now, but this is just the way that people think about it. So, the magnitude is defined as the sum of squares. No, sorry, it's the square root of the sum of squares of each component in the vector. And what that means is, well, this is our vector A, this is our vector B, okay, as is evident. And what we're going to be doing is, well, okay, let's just work through it. So it's the square of the sum of the squares. So the sum of the squares. So 2 squared add 1 squared. So 2 squared is 4, and then 1 squared is just 1. So 4 add 1 is 5, and then square root that, sorry. So it's root 5. Okay, so 2 squared is 4, plus 1 squared is 5. Square root of all that is square root 5. Now here, it's 1 squared, add -3l squared. Now -3l squared is 9, and then 1 squared is 1. So it's 9 plus 1, which is 10, and then square root 10. So it's root 5 times by root 10, which is root 50. So it's -1 over root 50. And then rationalize, so you multiply by root 50 over root 50. Root 50 simplifies to 5 root 2. And that'll give you this cosine A. I should say ACB, not ABC. But yeah, it's what we wanted. Question 17. The histogram below shows information about the height in centimeters of a number of plants. There were 40 plants between 7 and 8 centimeters tall. Michael takes 2 plants at random from the sample and does not replace them. Okay, so that's important. And he writes down the calculations for the probability, and its answer is this. Write down the minimum height of each of the plants Michael chooses. Okay, so we're told here that there are 40 plants between 7 and 8. And whenever you've got a histogram, you're plotting frequency density, like against whatever the other thing is. In this case, it's height. So, and the formula for frequency density is that it equals the frequency over the class width. Okay, we know the frequency here is 40. The class width between 7 and 8 is just 1. So it's 40 over 1, which is just 40. So here, at the top, the frequency density, that's just the frequency. Frequency density is just 40. And now, because there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, since there's 10 squares, and we need to share 14 to them, well, that's 40 divided by 10, so each square is worth 4. Okay, so just add that scale. Then we can use that to work out all of the other frequencies. So for this one, well, we're going 5 across the bottom, and the frequency density is 12, so 12 times by 5, which is 60. Here, between 5 and 7, we've got 2. 2 multiplied by 24 is 48. And then here between 8 and 13 is 5. 5 multiplied by 24. You can just think of this as 12 multiplied by 20, which is just 120. Sorry, 12 multiplied by 10, sorry, which is just 120. Okay, and then if we add all of these together, because this is the frequency altogether, we'll get the total number of plants. Okay, so if you add this all up together, you get 268 total plants. So we'll just keep that in the top right. Now Michael's calculation is this: so 30 over 67 multiplied by 16 over 89. Now the problem with this calculation is that it doesn't really tell us much in this form. And one of the big hints to kind of like figure out what Michael's doing here is, what is the probability out of? Well, here it's out of 67, and here it's out of 89. Now, the problem I have with this is, we'll just focus on this first one for now. If you're taking a plant out of 268, then that means the denominator is going to be 268. But here it's actually 67. So how has Michael gone from 268 to 67? Well, he must have divided by 4. You can think of it as 67 times by x, by whatever factor he's changed it by, equals 268. And then do 268 over 67, which is 4. So if you multiply this fraction here, just this one, by 4 over 4, and this one here by 3 over 3, I'll show you why later, you get 120 over 268 multiplied by 48 over 267. Now, this makes sense, because now we've taken one plant, so there's 267 total. So you would expect this fraction to be out of 267. Now, how has Michael gone from 267 to 89? Well, he must have divided by 3. So if you times this one by 3 over 3, you'll get 48 over 267. Now, I've just put this in a table. You really don't need a table, because you can just see it off here. But if the top one is 120, he must have taken out of this row. Okay. And the heights in this row are between 8 and 13, including 8. And 8 is the smallest in here. And we want the smallest height. So for the first plant, the smallest height must have been 8 centimeters, because that's the lowest here. That's the lowest possible height in that row. And Michael's taken the plant out of that row. And then for this one, 48, well, if it's 48, he must have taken out of this row. And the smallest height in this row, between 5 and 7, including 5, excluding 7, well, it must be 5. So the lowest heights must be 8 for the first one and 5 centimeters for the second one. So 5 and 8. And that's my answer.